Good evening and welcome to the next episode of the Cloud Builders. Today or tonight, or depending on your time zone, I believe we have attendees from around the world. We dedicate our event to .NET framework, .NET plus cloud, .NET plus satellite technologies. And we invited really awesome speakers to chat about this technology, to present their technical sessions. And of course, the main feature of our event is to have fireside chats. When I ask questions, technical ones related to particular technology, .NET and .NET plus cloud in our case, and we wait for your questions. So I remind that build-ups we run as a part of Cloud Builders initiatives have the following idea: bring your own problem. Yup. That means we want to help you in adopting particular technology, in solving a technical challenge you have with .NET or maybe something else. Just ask. Just use comments on YouTube Live, and we'll pick the most relevant, the most interesting questions, and we'll discuss this. So we are here to solve your issues. We are here to interact with you, and let's build this event in that way. So let's make it as interactive as possible. So our agenda for today is following. We have 2 technical sessions followed by 2 fireside chats. So 4 great technical speakers, awesome content. We had discussions with our dear speakers, and I really can't wait to hear their sessions. We start from the keynote by Dino Esposito, who is software and solution architect, who is currently active in machine learning and the general artificial intelligence area, plus smart cities. Also, Dino is a trainer with more than 10,000 hours of trainings delivered. He also delivered more than 500 technical sessions, wrote more than 20 technical books, and well over 1,000 technical articles, and not only technical, by the way. With the great pleasure, I want to invite Dino to our virtual stage. Studio, Dino, how are you today?
I'm fine, thank you. Just on a rush, as most of the people in the world, that is on business deadlines. So not much related to the time we're all over the world we're living, but the business times that it's pretty common. It's always been like the same in decades, I would say. But anyway. Happy to be here. Happy to start sharing a few thoughts about software in general and this particular aspect of software and this methodology, whatever name we want to use for that is called domain-driven design in .NET.
Yes, thanks for finding time to visit our cozy virtual studio, and the stage is yours. Tell us about domain-driven design and its relation with .NET, and we'll have a chat right after your session. I have some fun questions.
Absolutely.
Rock on.
Okay, so let me start, I guess, sharing that screen, or is that... Not sure, is it okay? Okay, hope that is okay with, not sure, it is okay with the screen. Sharing your screen, I guess so. Okay.
Yes. Now it's perfect. Please start. Yes.
Okay, perfect. Okay, thank you. I was just looking for this. Okay, so this is a talk that is trying to put together a few thoughts about domain-driven design. The DDD, D for domain, D for driven, D for design methodology that is at least my favorite way to look at it, available since 2004. So it's about 15 years, nearly 20 years ago. So it's been around for a while, I would say, but yet is a methodology or just a nickname, DDD, that leaves room for, let me say that, quite a bit of confusion. Now, I remember very well as one of the most interesting meetings of my life. It happened not that many years ago. I think it was in Warsaw, in Poland. I had a chance to talk to one of the guys who worked in the team with Eric Evans in the late 90s, early 2000s, during essentially the years and the first big projects that gave the spark to domain-driven design. So this guy was in the team with Eric Evans, and he repeated, talking to me about domain-driven design, a couple of words, one in particular, an adjective in particular, that you also find mentioned in the preface, in the introduction of the Blue Book from Eric, Domain-Driven Design. So is a methodology that has been devised from the grounds up to help teams to survive monumental complexity. So in other words, the scenario in which domain-driven design proves not helpful, much more than that, I would say crucial, vital necessity, is when you have a lot of business domain complexity to face. That's it. If you don't have a huge, tremendously big amount of complexity in the business domain, you may or may not be using domain-driven design. It won't make any significant, relevant difference. So, domain-driven design proves, for what has been my experience, and I've been practicing at least for 10 years. It's 10 years that I try to make sense of it and try to apply to business processes and software projects. It helped me more than in the writing of the code, the physical code, in the understanding of the business domain. Because if you don't understand the business domain, you're out of track. If you don't understand the necessary processes in the business, you're out of track. Once you've got a knowledge of the domain and sufficient knowledge of the processes, you have to understand the workflows through which those processes are implemented to reach and to satisfy the needs of the business domain. And then only at that point, you are in the condition of planning possibly better workflows. So this is where the monumental complexity belongs to. This is the realm of monumental complexity, and domain-driven design is probably the most powerful, if not the only tool we have as software engineers to tackle that complexity. And tackle is another verb that sounds familiar to those who have had a chance to look and to read the Blue Book from Eric Evans. There are essentially two parts in domain-driven design. One is a pure implementation. So the book contains a segment, a section that is about coding practices. And in this realm, you find a notion of a domain model, layered architecture, things like that. But there is another part of domain-driven design that I believe is much more relevant and significant. It's called, quoting from Eric Evans, strategic design, and it's centered around the 3 pillars, 2 of which you will see represented on screen, and it's the part that I would like to focus more. It's made of, I said, 3 pillars, 2 of which are ubiquitous language and bounded context. The third pillar is essentially, it's called the context map, and is essentially the geographical map of the bounded contexts you have identified in the business domain. Bounded context is, I would say, the theoretical foundation of modern microservices. Microservices is a much newer, fresher term than any other term related to domain-driven design. But if you grab the essence of domain-driven design, you will easily recognize in the notion of a bounded context, so a segment of the business domain, the same core idea behind microservices. Ubiquitous language, bounded context, context map. How do they relate together? Imagine that you are called to build a software model around a business domain. And the business domain can be treated as a monolithic block of concepts, of entities, of rules, of relationships, of processes, workflows, sagas, whatever. Or it can be split in multiple blocks, to some extent independent, or and that is the definition of bounded context, in blocks, in subdomains that can be treated independently. So a bounded context that can be summarized as being made by its own ubiquitous language, its own business language, its own implementation, which is independent from the implementation that might have been used for other bounded contexts. And independent implementation means may mean different technologies, different database technologies, different coding languages, programming languages, different platforms, and more importantly, external interface to stay in touch to the other contexts that are business related. If you take these 3 points, but in particular independent implementation and external interface to other contexts, these are pillars of the concept of microservice as well. The third pillar, context map, is essentially a graph in which the chief architect sees the various contexts and the relationships between them. Relationships in terms of a priority of deployment, but also rules of who controls which, who is the supplier of functionality to other groups. But I realize that I mentioned quite a few times already ubiquitous language without actually spending even a second trying to get into more details. Though it's not particularly technical, ubiquitous language is probably the most crucial point around domain-driven design, because it propounds the concept that the language used by the people in the business should be reflected as much as possible in code. This means a number of things. It means that the structure of the code in the end will be very close to the structure of the parts that make up the business. So it could be the organization of the company if it's a large company, or simply the organization of the business entities, the map of the business entities. It also means that any code you write should be ideally quite expressive, so that anybody reading the code, or at least the core part of it, should be able to read statements in a human understandable language. Don't think that it's particularly complex. At the very end of the day, a concrete example of turning your code into a ubiquitous language is as easy as instead of checking I don't know, a property on a class against a number and making if object dot property greater than 1. What does it mean greater than 1? Means is released. Okay, create a method called isReleased. Object dot isReleased is much more expressive and tells you and your team and even anybody else that has a chance to look at the code a much greater chance to understand what is happening. Again, the real value of domain-driven design is not much writing elegant code, but writing code you can survive the project. Why the pillar of bounded context is crucial? There are quite a few obvious reasons. If you are familiar with microservices, if you are a developer these days, I would say you will find all these reasons quite obvious. A bounded context is a functional area of the application that is preferable to treat separately. And this is a chance to avoid confusion when in your effort of understanding the domain, you run into the same term that means different things to different people. Ubiquitous language. The people in the business speak their own language for what they see and what they know about the system. It's your responsibility as a software engineer to try to make sense of what they mean by a certain word and reflect that in code. Sometimes the same concept, the same in the end, a database table or the same database record means different things to different people, and it should be treated differently. When this happens, you are on the border of two different contexts that are better treated differently. When you have a dependency on some external subsystem or legacy code, that is another great example of where a bounded context can help. But just to wrap up, as a separate, distinct, yet functionally controllable entity, the code that lives outside of your control. Again, sounds like microservices? Well, it is similar to microservices. Yes, again, I would call the concept of bounded context and the pillar, the strategic design of domain-driven design as the theoretical foundation of microservices. And now, there is another term that raises up frequently when we think of domain-driven design. It's events. But events have multiple correlated terms that end up pointing in very different directions. When we say events around domain-driven design, it could be event storming, it could be event modeling, it could even be event sourcing. The common point, the common base ground is event, but what happens on top of events is completely different. So event storming is, in my humble opinion, is the part event related that is more crucial for a successful DDD project, because event storming is a method, a number of practices you use to discover which are the things you have to learn about the business, how the various processes develop in the real world. And this gives you suggestion on how you essentially prioritize processes, extract workflows from processes, and understand the business. So event storming is nothing strictly code related, but is a methodology that, in brief, says sit in a room with a small number of people, a small number of stakeholders, technical stakeholders, ask them questions, expect them to give you clear answers, have them clarify about the processes, even have them also quarrel between them to decide what is the proper way to do certain things, figure out, absorb that knowledge, and then you are in condition to planning some software architecture and some software infrastructure. Event modeling instead is something that is more related to how you internally write the core code. So you have entities connected that represent behavior, and this behavior may have events. I'm not particularly fond of events in the domain, but yet they are a way to solve. They are a technical aspect of coding. Event sourcing has instead to do with persistence. So in a way, it's not strictly related to understanding the business domain. So it's not part of methodology. It's pure part of how you store your data and how you think the processes. Event sourcing means simply that whatever you save represents something that has happened, rather than being a photo, a snapshot of a state that you capture. We've been used for many, many years, for decades, since the introduction of relational databases, to think of the state as a snapshot we take, a picture of the reality we capture and persist permanently on a physical support. That's it. When we take a newer snapshot, we overwrite the previous and we lose track of what has happened before. There are many ways to avoid that, to keep track of the past while thinking of persistence in terms of snapshots. Event sourcing is a more natural way to approach this, which resembles how the human brains work. When we try to remember something that has happened in the past, our brains tries to rebuild the images that it has stored of facts and tries to reach a knowledge which is our memory iteratively. Event sourcing is nearly the same. You don't know exactly at any given moment in time the current situation, but you can rebuild it from the past. The classic, the canonical example that is commonly made to explain, to capture the essence of event sourcing is, think of your bank account. You know the state of your bank account, the balance, the current balance at any time. But that balance results from all of the operations, the transactions that you made in a number of months or years. And you can check them out at any time. And the final number you see is the result of what has happened in the past. So your bank account is built not by overwriting the number as the result of operations, but logging every operation and recalculating at any time the current state. Event sourcing is a revolution in terms of persistence because it forces you to make huge changes to your way of thinking software. It's a trade-off between an approach that is that goes against most of the consolidated techniques and ways of thinking, versus the benefits that could come only from the fact that you log everything. Do you really need to log everything? That is the question. So we have found now 3 different radically distinct aspects still put together by the use of the term events. And curiously, all these 3 things, totally distinct from one another, are often put and seen in the context of domain-driven design, giving spark to a significant amount of confusion. Of the 3 things, the only one that, in my opinion, is strictly related and useful in the context of DDD is event storming. Now, when it comes to domain-driven design, there are a few terms, a few names that pop up. Domain model, and with that, aggregate roots, value objects, repositories, domain services, and the synchronization between these 3 things. Domain model is in .NET nothing more than a class library with a few characteristics. Independent from persistence, made of classes that know nothing about the way they will be persisted, and also if ever they will be their content will be persisted. Very, very limited number of dependencies, mostly resources, data, maybe files, maybe JSON files with a list of countries, for example, resources like strings for localization, maybe in some cases some general purpose NuGet helpers. In some cases, I always found myself and my team encouraged to duplicate some code we had available in NuGet packages, putting in those selected pieces of code into the domain model, just to keep the domain model free of external dependencies as much as possible. The point is that domain model is your API, is your business API. And you should always think of domain model as something that others will be using. So whatever you make public out of the domain model should be devised or considered for public use. And whatever you allow through your API can be done through the backend. So if you, the popular Murphy law of software engineers, give developers a way to use the wrong API, and they will use it the wrong way. Related to domain model is the concept of levels of models. So there is not just one model. Domain model is one of up to 4 different levels of a model in a software application, software architecture. The first level is input. So there is a model for how you receive your data from the outside world, and you get ready to process it. The domain model is how you deal with your business entity. The data model is how you persist. The view model is how you render data back to the user interface. Now, the domain model, in terms of .NET jargon, is a plain C# class library. The data model is entity framework. Most of the time, those 2 things match up. We create the model for entity framework, but we miss the point that the model for entity framework to work poses us some constraints. For example, we must have a default parameterless constructor, which sometimes we don't want to have in a class library that is devised for communicating with the outside world at the business level. I don't know. Let me make a quick example. My current business is in sport. So let me use the concept of a sport match, whether it's football, is tennis, or whatever it is. We have a match, but the instance of the match class that we have in a domain model, you cannot have in business a match if you don't have also the team that are competing, or maybe the venue, information about the venue, the day of the competition, and maybe some other information. Without some of those pieces, it makes no sense at all to even talk about a match. So you might want to build in the domain model a match class that has a factory or maybe just a constructor that accepts mandatorily a number of parameters. Without any of those parameters, you don't have a valid instance of the object. You should throw an exception. This is business-wise. When it comes to persistence to entity framework, we are not allowed to have a class that is parameterless. So we have to release some of the constraints that we see in business to make the class easy to persist and work with in entity framework. And sometimes I see the confusion in detecting that we are really talking about two different logical levels, abstraction levels, different. The domain model, which is persistence free, and the data model. We create one model within entity framework and pretend it works through the entire stack. This is conceptually wrong, even though it's sometimes and more often than not is an acceptable compromise, but we should be aware that it is a compromise. Now, entity framework. In terms of .NET, we cannot talk DDD without entity framework. I do remember the days, the early days, very early days of object spaces. It was 2002, 2001, or something like that. It was the ancestor of modern entity framework. I also had a chance to work closely with the guys, the early guys who built up the first 1.0 version of entity framework. My thoughts is that it's definitely helpful. It's much better to have it than not. It's slow. But it's slow, I would say, by design, because it attempts to let people do a number of things quickly, in a safe way, and without deep understanding of the underlying data structure. Entity framework cannot be made much faster or leaner than it is now. I just read a few days ago the plan for entity framework core 6. And at some point, I believe they say clearly, don't expect magic. We cannot make it much faster than it is now. It's a matter of structure. It's a structural point. So if you're looking for a great way to persist data, a fast way to persist data, and you choose entity framework, you're on a dead track. Entity framework is great to let you write an infrastructure layer quickly, quite effectively, safely, but it's not and will never be just for performance. So in summary, an application can be seen through a number of layers: front-end, presentation, persistence, in which you find a number of repositories. And when we talk repositories, we connect to the concept of aggregate roots in domain-driven design. An aggregate root is the object, the core object that contains a graph of sub-objects and controls their persistence. Identifying aggregate roots is a challenge. But we're talking about the purely persistence. From repositories down to the physical store, we go through entity framework, any other ORM, maybe Dapper, ADO.NET, or plain SQL code. On top of persistence, we have a domain model. And side by side, we have application services for the part of logic, orchestration logic that is related to the UI, and domain services for the part of it that is related to persistence. In terms of a mapping to .NET, I would say that the front end and presentation, if we consider a classic web scenario, we have an ASP.NET Core project containing CSS, HTML, controllers, and application services that links to a .NET Core class library for the domain model that has no dependencies whatsoever and is referenced by another infrastructure class library. That is where I expect to find the persistence entity framework classes, repositories, maybe domain services, and any other service like those that connect you to email services, external APIs, or maybe dependencies on a legacy code. This is a summary, and it is also about the time that I wrap up my presentation and just wait for questions. Organizing a talk on DDD in 30 minutes is quite a bit of a challenge. I did that looking at some of the questions that were asked before, but I expect that there are more questions that I can hope clarify in the rest of my time here. Maxim?
Thank you very much, Dino. You made it. Yes, DDD session in 30 minutes. That's amazing. It's really mind blowing and mind twisting, and something to really think about when you start a new project. And I think that many of our dear attendees have a very simple question. So. Yep. I start a new .NET project which I plan to, for example, deploy to the cloud later. Do I need to involve DDD here, or it could be more or less classic in my particular situation? What kind of guidance could you give to the developers about where to involve DDD or not?
As I think I said specifically at the beginning of the talk, DDD is about facing monumental complexity, just to quote the inventors, the creators, the smart guys that came up with this set of rules. It's a practical survival rules in the context of a complex and I think the original project was a logistics system. A chance to work on to do some consulting on DDD in logistics. I was some five or 6 years ago. I learned that since the beginning, so 20 years ago now, only three platforms exist to cover the entire logistics in the world. And one of these was created by the team. The first release at least was created by the team, who then decided to publish the guidelines of DDD just to explain how they made it. So it's the point of complexity that is really the crucial point here. I tried many times, honestly, to apply since 2006 or 7 when I first approached DDD. Okay, let me follow step by step the rules, the guidelines, and do this and do that. It ended up, for the most time, being a sequence, a collection of practical coding rules, like, don't use classes that have state, or you create classes with value objects, or don't use integers but use ad hoc types, don't use constructors, things like that. Now, tell me, how is it possible that a business code is better or not, or worse, if you use constructors or factories? I can't believe that. We are still talking code that works or doesn't work, a code that is manageable or is not manageable, code that can be extended, improved, or evolved in some way or not. Again, in the end, it turns out that using a factory instead of a constructor is helpful. It helps you, hitting the nail of keeping your code easy to read, easy to evolve, but it's not the point. Not because you use a factor, your code is better. Your code turns better, and in the end, you realize, oh yes, that helps. That's helpful. So it's a point of having enough complexity. Now, even though I confess that I never, and it was my decision, spend much time in enterprise software development. I always tried, as you from my resume, you can easily figure out. I always tried to work on the side of that. But every time in my career I ended up being involved in enterprise projects, very rarely I've seen the need for spending time breaking up things according to the guidelines of DDD. So it's not really for every project. On the other hand, I have to confess that just on the current project, which is not exactly very complex, and I wouldn't define it monumentally complex, but in that case, it's a strongly business oriented, and I have to understand the domain. I have to figure out the processes, the workflow, and using expressivity rules mediated from a ubiquitous language and isolating context and having clear who does what and who depends on what, the context map, that is making everything smooth and clean and elegant. And just today, I realized that making a relevant business change proved a snap, because everything was laid out earlier. Because of having, probably absorbed in mind the key concept. So I would recommend domain-driven design to be part of the personal knowledge, personal skills of every software architect. Whether it works or not for a project, it's something you realize along the way. It's part of your being, or your being a professional. There is no project in which you can or cannot use it. So I think just understanding this point is crucial. It should be part of you as an architect rather than part of the project.
Yes, fair enough. I didn't expect a simple answer. I think you nailed it. Very good. Unfortunately, we have literally a couple minutes left, and we have many more questions. Let's do the following. There is a link to YouTube live streaming in the chat of the Zoom. Maybe you see this. So if you could dedicate some more minutes to stay online and to go through these questions and answer them by text in the YouTube, we all appreciate, and our dear attendees appreciate this.
I'll do that.
And a quick question from my side. Literally, we have only a few seconds. So to connect even more your topic on DDD and .NET, any libraries, any helpers, any frameworks in .NET to help with adoption and driving and running DDD? Just some names.
I believe that more than frameworks, the C# language has a feature that I personally find extremely helpful, and this has been there for many years. Two of them. One is partial classes for physical separation of because you have an entity, that has may have fairly complex and have multiple differently related sections, and partial classes, I believe that helps significantly to keep things separated while under the same umbrella. Second is extension methods. Extension methods are extremely powerful because they help you out adding at any time business-oriented methods, which helps immensely to keep your code absolutely readable. And in addition to that, the foundational fact that when you create a class and you define properties and methods and whatever, you should think on the business things in terms of methods rather than in terms of properties, because any change of state depends on an action, so everything has to be a method. And properties should be read-only. But this is just in general, a guideline. Extension methods are helpful because on classes that exist or classes you don't control, you can still add a readable method that makes your code fluent, and also fluent programming. That's another one, another big one. Fluent programming, all features that directly or indirectly belong to the language. So more than packets, more than NuGet packages, I invite you to take advantage of the C# language.
Awesome. Yeah, this is great advice. Use the power of language you work with. Everything is there. Just start using.
Yeah, C#, by the way, is a fantastic language. So.
I fully agree. I fully agree. Thank you very much, Dino. Yes, please dedicate a few minutes to answer questions on YouTube Live. Great session. Thanks for answering the questions, and have a great evening. Bye-bye.
Bye.
Okay, so welcome back. Welcome back to the Cloud Builders build-up dedicated to .NET. And I want to introduce our next speaker and the next topic. We'll talk about continuous integration and continuous delivery in .NET with Serhii Seletskyi, who is a senior solution architect in Intellias. Serhii helps IT companies for last 15 years to harness and to choose the right technology stack to scale their business and make it future-proof. Serhii is a certified Azure solution architect with extensive knowledge in a wide variety of innovative cloud-native solutions for different business domains. Welcome to our virtual studio, Serhii. And
hello, .NET engineers. Thank you, Maxim, for introduction. I thought about this tech talk and actually CI/CD because I had many interviews with .NET engineers last time, and I found that many projects, many .NET projects still don't use proper CI/CD processes. Usually they have a kind of CI process, but it's not even blocking pull requests, and even sometimes not running full scope of tests. And so it's why I'm here today, and so probably I will share my presentation.
Yes, please do. Yes, I can't wait to hear about the best practices in CI and CD for .NET. The stage is yours.
Okay, thank you. I hope you can see my screen right now. Okay, so today we'll talk about different types of pipelines that we have, not only in Azure DevOps, but overall in automation, CI, CD, and other types of continuous automation practices. About .NET project repository structure that you should follow indeed to use these practices in the right way. Little bit about Roslyn analyzers for .NET and Sonar Cloud. And of course, few words about releases, but it's out of scope of this short tech talk. So what is good CI? Good CI is CI that helps you in some way. It was created because of that. And if you wait for a build for an hour and your changes still merged into some develop branch and work of other developers is broken, it's not a good CI. So from my experience in many projects, I collected a few rules how a good CI process should look like. First, you should have a gated quality builds that should block pull requests or other things that you have in maybe not in Azure DevOps, but maybe in Mercurial or other systems. But in Azure DevOps, we have gated builds that block pull requests to target branch, and you validate with it your code. Second rule, it's like 5-minute rule. If your build running longer and pull request is blocked, and usually developers not create code from first try. Usually it takes a few tries to fix tests, to fix coverage, to like refactor code in proper way, and also to fix code review issues. And every time you push extra changes and rerun the build, and it can take like 5 times. And if your build takes like 20 minutes, it would be a waste of a few hours every day. And it's a bad CI. It's better to code without any CI than really slow CI. And another part, your CI should run tests because you write tests to validate your code. And if it's only running nightly, like nightly integration tests, there is no sense of this test, because at night you see that something is broken, and you probably won't fix it until some time, and there is no sense in it. So you should optimize your pipeline to run every possible test that you have, except some extra complex cases which involve infrastructure deployment and takes a long time because of that. Other things you can parallelize. In .NET we have Xunit, which run tests in parallel by default, and it's really good framework. I love it, and we run basically thousands of tests in less than a minute on some project, and I think it's worth including all possible tests, including contracts tests in pull request checks. Also, good CI should run code convention for team. If you have some code convention, some agreement with team how you should name different types, methods, etc., it should be validated on pull request. Code reviewers, of course, cannot review all code and always find badly named method, and computers way better than humans in this task. So let's simplify work for code reviewers and just add extra linters, Roslyn analyzers, other tools for doing such job. And of course, you should publish metrics, because without it, you have no visibility how your CI process behave, how many times developers retry usually, how much time they waste running these builds, what metrics of code quality, duplication, coverage. For this, we have a great tool called SonarQube or SonarCloud. Let's discuss example of one of our projects. It's our internal projects, and we have quite a lot of pipelines. It's just 5 microservice projects.
Serhii, I'm sorry to interrupt you, but could you please minimize Zoom window, because it partially intersects with your screen area, so
Okay.
cannot read.
It means this one. Okay.
Yes.
Now it's better.
That's fine. Yes.
Yeah. So sorry for that. We have 5 microservices project, And as you can see, we have way more pipelines for that. So for every microservice, we have separate repository. And for each repository, we have a few pipelines just for CI. So first one is gated. It's most important one, which do validation of code quality, running build and tests before actual merge. After this code is merged, we run another pipeline which build code in release mode and create packages of NuGets and create Docker containers and push it to artifacts. In this project, we have one more pipeline, which is deploy pipeline. This pipeline is for infrastructure as a code. As we have clouds like Azure or AWS, we should have some automation to deploy infrastructure and resources. Sometimes DevOps create a separate repository for infrastructure and support or all Terraform or ARM templates in that repository. It's actually not a good way of managing that because microservices, first rule is autonomy and isolation. So you should put every dependency that's related to this microservice in microservice repository to have full autonomy and to be able to spin up this microservice without any extra collaboration with extra team or extra dependencies in other repositories. So in Azure DevOps, we have a great feature called directory filters for repositories. So we just configured this deploy pipeline to be run when pull request created and only specific content changed. Only when Terraform changed, this pipeline validate Terraform and upload it to artifacts to be used later in infrastructure deployment. Overall, this flow looks like this. We have a pull request, then gated build. It's running usual .NET restore to pull NuGet packages. It builds code, then test and running coverage analysis, linters and Roslyn analyzers, and after that, Sonar analysis. What's important that Sonar should be blocking here, because on many projects that I saw, most people using Sonar just as analysis tool. And when it's red, it's not blocking anything, it's just red, and code is merged with developer master, and that's it. So in order to properly configure this, you should create a blocking service in gated services for a repository to receive status of Sonar for a specific pull request and block pull request if anything wrong with it. Otherwise, it makes not much sense to adding Sonar or depend on other tooling. After it's merged, you want to create a proper build for deployment without any extra debug options that you enabled for coverage collection. Built in release mode, then you packaging NuGets, building Docker containers, pushing NuGets to NuGets repository, and publishing artifacts to Azure DevOps artifacts. And basically, these artifacts triggering next stage is continuous deployment, continuous delivery, which is different types of pipelines in Azure DevOps, and it starts rolling updates for your environment. Then basically also restoring dependencies for these artifacts, then run infrastructure as a code. As I told, it's prepared by another type of CI process, and basically deploy artifacts onto updated or created infrastructure. And after that, important step is verify if what you deployed is working correctly. because Azure DevOps may deploy this artifact to web application or Azure functions, but you may forgot some environment variable, and this application just not starting. It's deployed, but it's not starting. And without this verification, Azure DevOps will start rolling this update onto other environments. But actually, it's not working, so you don't want that. So you should have specific step for validation. In our case, we have a gated pipeline looks like this. We have some tricky parts here. For example, we have usual restore and usual build. This build run regular Roslyn analyzers. Then we have a prepare sonar analysis task, which actually inject some plugins into MS build infrastructure, and then we run specific build for sonar with these plugins to collect analysis data. Otherwise, we will have a conflict with Roslyn analyzers if we will build it in one step. After this, we have infrastructure creation for specific resources that we use in integration testing. Then run tests. In this part, we run XUnit tests for our unit tests in the repository, as well as integration testing, and connecting it to real infrastructure in Azure. And this is not a long test. Basically, to create infrastructure, usually it takes like 15 seconds, and then run all tests for one microservice. If you have proper separation of bounded context in your projects, your services shouldn't be very big, and you should have less than 1,000 tests in one project, in one microservice. Yeah, and you can run it in like 30 seconds or so. Then, of course, publish coverage, run sonar analysis on results of this MS build and tests, and publish it to sonar. In our case, it will block pull request if something bad happens. If you don't configure it properly, it won't. And feel free to use extra tooling like ReSharper or Endepend. It's up to your team what tools have experience with and what is useful for you. And remember about parallel jobs in Azure DevOps. Not many people using them or even know about them, that in one pipeline you can run a few parallel tasks. And if your build running too long, like 10 minutes, you can just identify some steps that could be run in parallel. In our case, it's contract tests. Yeah, basically, this is type of tests that run compatibility checks across multiple microservices. So basically, it's pulling code from like 10 repositories of a related group of microservices, then create infrastructure for them in real Azure disposable environment. I create resource groups for them, resources, then deploy these microservices, and basically run tests on top of these microservices. So this is a long part comparing to all steps that you have on primary job for build with sonar analysis, etc. And both of them take about 5 minutes. So as they run in parallel, we have just to wait 5 minutes to run all of these tests. And this is not a complex pipeline. It could be created just in an hour or so, even with Sonar Cube setup in cloud. So it could be accomplished by any .NET engineer, and it definitely worth in investing time in that, because you can save a lot of time for your team, and you can save a lot of time for bug fixing and improve code quality dramatically on your project. Okay, then our repo structure. You can create whatever repo structure you want, but usually it should contain a few parts. So you should have a source directory with your C# projects, and it should be separate from test projects, because not any tool analyze properly C# projects, and you don't want your test projects to be in analysis for example, for code coverage. You don't want to configure something extra to exclude this. So just to make things simple, put your actual code in source directory and your tests in test directory. Then it would be great to have a separate build directory built as a code. So you can put YAML files of your pipelines for gated build and regular CI build into that. And also deploy folder. In our case, it's ARM templates for Azure, could be Terraform or other types of scripting for infrastructure. And as you can see, we have also regular Git files like gitignore, have also directory build props. This is important file for sharing general cross-cutting logic with analyzers and common components that we don't want to include in every project that we have, and also Intellias rule set, which is like team code convention that we use, and it enables write rules in Roslyn analyzers. And it looks like this. Basically, you can find this in my GitHub if you want to reuse this rule set. And right now you can see build directory props. So we use a couple of analyzers here for C# rule set from Microsoft, Microsoft Code Quality Analyzers, .NET Core, Security Code Scan, and text analyzers, which is basically spell checking. And it works perfectly in Visual Studio and Visual Studio Code. So for when you type something wrong, it's just fix it automatically. And when you push your code to CI, the same analyzers analyze your code. So if you disable it locally, doesn't matter. Him will not receive your like broken code or broken convention. Important part here is debug property conditions. For debug configurations that you run on gated build, you should have a debug type full with full analysis of code. It's important for proper code coverage analysis. And for release, you don't want this stuff. You don't want PDB files. So in most cases, yeah. So you could select portable. And also very useful thing is tracking warnings as errors. We always enable it. We follow no warning like practice. And basically, if you have warning, you can fix it in your IDE. You don't want to push it to code review. And a new feature in C# is nullability checks. So if you tired of checking if something is null and then throw null reference exception, just use this option, and compiler will automatically check for nullable types, and you basically will be forced to use non-nulls in your code, basically. Yeah. Sonar Cloud. It's crucial tool for any projects right now, and what is good about it, it's free for open source, and it's really cheap comparing to any other tooling for commercial projects. It's just $10 per repository, so any project can afford it, and it's way cheaper than NDepend, for example, which costs like more than $1,000. So important step here is that you should configure proper integration with Azure DevOps. Because by default, if you just add steps into your CI, this will work as analysis tool. And if something is broken here, you can go here and see that it's broken, but it's not blocking your pull request. So you should create personal access token in Azure DevOps and put it in pull request analysis configuration of your project in Sonar. So Sonar could go to API of Azure DevOps and create comments on actual code review as a reviewer and basically block your pull request. And also on a particular branch, you should configure a quality gate check for Sonar. So when you run your quality build, it will also be blocked. And it's very useful tool. We basically treat it as extra team member in our team that like reviewing more code than any other engineer in our team. Very, very interesting thing. And the most, let's say, regular one is post-merge build, which most people are using. It's just built when you merge code to some target repository, like to developer or to master. It's in our case, it's simply just build code because we already have everything pre-validated in our, let's say, master or develop. And we just want to build a production version of our application, create packages like Azure function packages or Docker containers, and publish it to artifacts. And as well, important part for microservices that you should publish SDKs for your services, like NuGets SDKs with REST clients or NPM SDKs, because Open API is good thing, but you anyway should have some end-to-end testing. You should have integration testing, and it's good to have such a clients that could be used in other services just by NuGet or in front ends, and as well in tests. You can use this SDKs in tests, and it will simplify your work with these contracts because you just pack contracts, you just pack REST clients for your services or GraphQL clients, and you can validate if this clients works properly in tests, and consumers could also use this tested artifacts. And last thing is release pipelines. Usually we have multiple environments, like usually 3 environments for continuous deployment, develop, testing, and staging, and 1 environment for continuous delivery. So between these 2 groups, we have a approval stage. So when everything fine, everything deployed on these 3 environments, QAs can test, UAT group can test on staging, and if everything all right, they just press their approval before production and approve these artifacts for deployment to production. This is simple scenario. You may have some comprehensive A/B testing with more environments. On some projects, we have more than 10 environments for each service with different aspects, with canary delivery, with A/B testing. But for most projects, usually it's just 4 environments. And just recommendation for me, don't use blame-driven development. When something not working, just try to brainstorm with your team members and use engineering culture and try to find root cause of problem and fix it with team. Don't find some person that created bad code and you don't want like review this code, something like that. Also, in Scrum teams, we often use definition of done. So if some parts of this definition of done could be automated and you can check delivery of these steps in definition of done, you can automate it in pipeline and also simplify work for you and show to your product owner that you follow agreement. And one more thing, it's refactoring. Refactoring is part of development, as for me. And if you don't have a proper CI/CD, if you don't have Sonar, you will have a problem because technical debt will grow, and you should communicate with customers that you should have some time for refactoring. As for me, it's wrong. You basically cannot push your code to repository without refactoring, because you should follow a lot of analyzer rules, and this what I think is a good practice to create CI/CD at first, and then force refactoring and engineering culture in your team, and don't grow technical debt. Yeah, and regular one, build once, deploy many. We have artifacts. So if you can deploy some artifact one time and reuse it, just don't use too much power of your building infrastructure and agents, because it will slow down overall pipeline speed if you don't enough resources. Then, so don't duplicate steps on pipeline if you can, and just reuse these artifacts. And invest in your build agent. For gated builds that we use in pull request, we have a dedicated server for that, and this server saves us a lot of time. Basically, in year, it's more than 1 month of development development time, and basically, if you calculate, every developer may waste 1 hour of development time for deployments, test running, etc. And if you have a faster machine that can run it 10 times faster for entire team, you save a lot of money, and it makes sense to invest in this. And so always we have a lot of vacancies in our company for .NET projects. So if you want to join us and work on great projects, just scan this QR code. And thank you. That's it, Max.
Welcome back to the Cloud Builders .NET edition. I want to thank Serhii for a great and very practical, very hands-on session. And thanks for your questions, dear attendees. I hope that Serhii will find time to answer them on YouTube Live in the comments, like Dino did. Thanks very much, Dino, for answering, I believe, every single question. And we have now in our virtual studio Rosemary Wang from HashiCorp, developer relations specialist from this amazing corporation, which is very, very relevant to everything about the cloud. Good evening, Rosemary, or good day for your time zone, I believe, right?
Yes, it is. Hello, everyone. Thanks for joining, and thanks for having me, Max.
And just a few words about Rosemary. She works to bridge the technical and cultural barriers between infrastructure engineers and application developers. She has a fascination for solving intractable problems with code, whether it be helping an infrastructure engineer learn to code or an application developer troubleshoot infrastructure failures. So it's all about mix of dev and infrastructure. And by the way, in our fireside chat, I believe next 15 minutes, we continue the session, the topic started by Serhii. It's about all things around continuous integration and continuous delivery in relation to .NET, in relation to the cloud. And we gathered so many questions from your dear attendees on that topic. So yeah, we cannot dedicate, let's say, too much time to this, right? So it will be always not enough time to chat about this. But let's start. And the first question will be maybe a bit tricky one. What can we do? What can we do as developers or DevOps engineers to speed up all these continuous integration processes execution, maybe without too much handwork, without introducing too many changes? Are there any silver bullets? What do you think, Rosemary?
There are never silver bullets. It always comes at a cost. And some of the tricks that I take to speed up the CI process include looking at tests. The idea is, do you need to run every test? Do you need to run it every time? And sometimes the answer is no, you don't have to run every test. Sometimes the test is redundant. Sometimes you're asked to do it for test coverage and it's not improving any functionality or it's not assessing it. So sometimes it's a matter, usually quick way to do this is to go back to your tests and take a look. Are they effective? Are they doing what I think that they're doing? And does it make sense? Sometimes it adds additional time to it. The second thing, it happens from an infrastructure perspective, and it is not as easy to implement, but some of it might be if you're using containers, for example, as your continuous integration build agent, you might consider caching layers or taking certain things out of the build agent so it's a little bit lighter. So sometimes if you're using a build agent and you're installing a lot, that adds minutes to your pipeline and to your CI processes. So sometimes it's taking a look at the build agents and seeing how much you can build in to those images already.
Yeah, I see that you are an expert in everything related to infrastructure. So could you tell us a bit more about your involvement? What are your personal points of interest in this technical area, and maybe is it somehow related to the .NET in particular?
Yeah, so I work with a number of .NET developers, and I consider myself sort of in between. I guess that's the true meaning of DevOps, although sometimes the definition is hard to say. But a lot of the times I've learned development from some of the best developers, Java and .NET. And because I've learned from developers who are much more expert in the application space, I've been able to take that knowledge and apply it to infrastructure, and how you can build infrastructure better to lower the developer friction and make the developer experience better. So, the intersection usually happens between metrics and observability, continuous integration, testing, and anything that has to do with the application retrieving information from infrastructure systems, whether it be databases, queues, secrets managers, and everything else. Infrastructure is a very broad space now. There are a lot of things that can be infrastructure. And as someone who works as, I guess, more of an infrastructure specialist, it's my job to make sure that developers are able to do this with as little friction as possible.
Yeah, then I believe the next question will be sort of follow up to what you just told. So someone during the registration to this build up asked a question like this. Netflix says that there is no DevOps in their company since it's the job of a developer by default doing this kind of activities. Other companies, they hire specific DevOps engineer, or even maybe even more specialized, like for example, DevSecOps engineer. So it's like whole department of folks like that. So what are your personal thoughts on this? Is DevOps relevant perspective in terms of career and everything, or it's still something that let's say developers can do and should do?
I think that it ends up being both. My first job in the technology industry was a DevOps engineer, and I joke to this day I don't really know what that meant. I still don't think there's a good definition for it, and I think it's a matter of being specialized or general, right? Mm-hmm. At the end of the day, DevOps is a culture, it's a principle, it's continuously learning. And so the titles end up being important to a certain degree because you have to know what you're doing day to day. But part of this is being open-minded and learning as much as you can, even if it is outside your comfort zone. So Netflix is not wrong. It is development work by default. If you're a system administrator, you are doing a form of development. It is very specialized. It is just like someone who understands .NET very well. And I think that at the end of the day, yes, we're all becoming developers, but DevOps is a mindset. You become more adept at learning operations responsibilities as part of your development work as well.
Fair enough. Yeah, I really love this classical definition of DevOps. This is how it says mix of culture, tools, and processes, something like this, right? And culture is very important, and title, yes, is still very important. It's good to be on the position where you understand what you have to do, and you do specifically what you was hired to do, which is DevOps. Okay, I have set of more concrete technical questions. For example, what is the better way to configure CI/CD for artifact management? Maybe you can mention some tools, helpers, frameworks, or best practices.
Sure. So it depends on the artifact, right? Artifact can be many things now. It is either a NuGet, some NuGet package. It could be container. It could be, virtual machine image. It could be a serverless function. There are many forms of artifacts now, and so the phase, what you'll see are the typical phases, right, of a CI platform, which is you deploy, you test, and then you release. So if you concentrate, deploy, test, and release, you'll always get one of those. And the artifact piece, or the important part that we don't do well or we don't think about, is this versioning piece, which is you deploy, test, and when you release, there's a part that's version, right? How do you put a new version out there without someone picking up the wrong version or it's breaking changes when someone updates? And so when you try to configure a CI/CD, I try to avoid too many special processes. I try to boil it down to those 4 stages and focus on what I get out of the box for versioning, right? So this could be Git versioning, which is very popular. That's a very popular way to release even open source. And for example, HashiCorp tooling, we release by Git tags. You could also use some other forms of tagging and release management. That's where the artifact registry comes in, where you can deploy to some artifact registry. At the end of the day, there are many CI pipelines and frameworks you can use that have this out of the box. And They even have some really good language detection as well for Git commits. And you can use that language detection to automatically release subversions or versions for your artifacts as well. So it's a very general view. It's very complicated, but most tools are offering the capability these days.
Mm-hmm. Awesome, awesome. If we go back to .NET topic, like more specifically, what kind of cloud agnostic tools, maybe open source ones, could you name for helping with the instrumentation to provide tracing, monitoring, and all this, let's say, infrastructure parts of the development?
Sure. So if we're moving toward cloud instrumentation and monitoring and metrics, I have to plug the Open Telemetry project. There are the tracing space and the monitoring space in general for no matter which tool, regardless of .NET or any other library, has been very wide and very special, right? So it's usually very specific. And so now we're moving toward kind of a contract or a good schema for instrumentation and monitoring. So Open Telemetry is the one that we are building. It's in the process of construction, and it will work with a number of cloud agnostic platforms, whatever monitoring you choose. It also allows you to output as Prometheus metrics, right? So if those who are not as familiar with Prometheus, it is a very easy way for you to output the metrics and consume them in a standardized way. I would say that's probably become more standard in the cloud space now. So check out Prometheus. And Open Telemetry is the convergence of a lot of instrumentation and tooling that's more specific to the application. You can also use a number of .NET application libraries. I've used AppMetrics in the past to retrieve information. It also has a lot of outputs to Prometheus and many others. There's Prometheus.NET. So if you want to take the .NET metrics and output them to Prometheus, there's also libraries around there. And tracing is a whole other beast. There are many other tools you can use, infrastructure layers like Service Mesh on top of these .NET application libraries that allow you to do tracing from a network level, from a request level as well.
Mm-hmm, mm-hmm. Yes, you perfectly answered the question what to use, but if you do step back and encourage dear developers to use these instruments more frequently, more often, let's try to inspire them. So why do you think tracing is important while you build and run your .NET application? So how will this help to develop up?
Yeah, and it's a lot of people ask me, why do I invest in changing my code to accommodate for tracing? Because tracing is very difficult even to implement in your application. But when you have, when you're building so many, especially on cloud infrastructure in particular, it makes it very easy to deploy many instances of your application. And with this drive towards smaller applications, more consumable, we can talk about microservices. But even if you're using an application that's across multiple platforms, it could be .NET in your data center and .NET in your cloud. The problem is you don't have much visibility into where requests are going, how they're going. Are there problems within your code that you can fix that might alleviate either the transaction time or errors? So tracing is really helpful because it helps you partially debug, right? So you don't know what you don't know. This is where the observability space becomes very important. You don't know what you don't know. And if you are developing applications across multiple platforms, cloud, data center, container, VMs, you need one pane of glass, one piece of visibility that allows you to see where those requests are going and how you can improve. So tracing is very valuable in that you are able to understand how the timing in your application, but also across the network and across many platforms.
Yeah. So I fully agree that it totally makes sense to invest some efforts in building robust tracing in your .NET application. And if we talk about monitoring, what kind of metrics would you recommend to gather during the runtime of the application?
So depends on the application, and there's the complexity around it. It depends on the application you are running. If you are running a web application, right, you do want to have the golden part of the golden signals, right, the Serhii golden signals. I am not going to list them all right now because there's, but there are the metrics that you can surface from the application, and those are more network related. So latency, for example, how does one request from one application get to another? Internal, there's also, of course, garbage collection, memory, the usual system, application running and system metrics as well, that are helpful, and you can use those to debug for performance concerns. But again, it will heavily depend on your deployment model for your .NET application, where it's being deployed, how it's being deployed. Sometimes if you have a very large .NET application, you do want to surface those application metrics, right? The more detailed ones. Versus if you're using something on containers or cloud, you might get that out of the box, right? By the container compute platform or monitoring it for you. Or if you're using something like a service mesh, the proxy itself will be able to surface the network metrics up and therefore give you the 4 golden signals without you necessarily gathering them directly within your .NET application itself.
Yeah, super. I think this is these were main questions I had for you, and let's just sum up. What can we say to .NET developers about everything related to infrastructure part of their applications? If we talk about instrumentation, tracing, monitoring, just give I don't know, some general advice, some general recommendation to dear developers.
It's very tempting to implement everything multi-threaded, right? So it's very easy to use an SDK. It's very easy to use a library that's out there. But in some infrastructure patterns and platforms, that's not always the case, and that's not always so easy to use. So if you're a .NET developer who's working on a legacy application and you're concerned about adding some of these new libraries for instrumentation metrics, it might be worth investigating other infrastructure layers that you can add that you don't need to code using an SDK. So there's a model right now, which is multi-process, which is the sidecar model. They call it the sidecar in that you have your application and then you have a binary that either does collection or proxying network traffic and might give you the opportunity to have sort of instrumentation without adding new code into an older application. So that's a general pattern. I recommend take a look at a sidecar if you can, if you don't want to write a good amount of logic in your application code base to handle retries, etc. Take a look at that. And the second is that always reach out to anyone you know about infrastructure. It's complicated. I can tell you that I have not fully learned everything in the infrastructure space, and I've worked in it for so long. So don't be intimidated. Reach out to the communities if you are interested in any of the infrastructure components. It does not mean that you need to have cloud certification or anything specialist, but if you do need assistance and you want to learn more, there's a big community who's interested in helping out and learning with you.
This is great advice. Always rely on the community. I think that power of dev community is just amazing these days. So you'll always find answers on your questions and help from folks who solved challenges like you have now. Thank you very much, Rosemary, for your time, for your answers. If we have some more questions on YouTube Live comments, I hope you'll jump in there and answer. And have a great day. Bye-bye. Okay. Alex, are you ready? Welcome back, dear attendees of the Cloud Builders Buildup.net edition. We have our last but not least session, which is a fireside chat with our special guest from the Netherlands, Alex Thissen. He's lead consultant at Xpirit company, and Alex always been about the combination of technology and people. Alex likes to share his knowledge as an architect, developer, trainer, and coach with anyone who wants to learn and improve. Welcome, Alex.
Hi, good evening, Maxim and all attendees. Thanks for having me.
Thanks for joining us. Do you want to say a couple of words about you, what you do in the cloud, and what you do in the .NET area? What are your, let's say, special points of interest in .NET universe?
Oh, okay. I work as a cloud architect and consultant, and that way I get to visit many companies and see what they're doing. And well, in their transition to cloud, it's the change of architecture, getting to know how you can build cloud native applications and how you can make them resilient, maintainable, cost effective, and how you would do that in a combination of getting things from the cloud as software as a service, but also building it using the .NET platform. And that takes a combination of, well, your own code, the platform as a service, cloud resources, and how to do all of that in a, well, usually a diverse landscape, ranging from on-premises up into the cloud, legacy applications, and all of that combined, and how do you move that forward into the future?
Yeah, then that means that we have lots of topics to discuss next 15 minutes. Let's start from the questions sent to us by dear attendees of the event. For every build up we organize, we have a special field in the registration form with the question. So just imagine there is a small company, let's pretend this is a startup, where only 3 developers, .NET developers. What could be the cloud adoption model for this mini team, for this mini company? What are your thoughts on that?
Okay, yeah, that's a good question, because I think that a lot of companies are doing that, and they can be really small, as in 3 developers, or it can be a part of a company doing that. The cloud adoption model, well, I think first of all, it's about getting the skills in place, and Rosemary already hinted to this. A modern way of developing application is using DevOps, and the way I see that is that you have a team of engineers, software engineers, and they do development, but also creating the infrastructure, like provisioning that into the cloud, building the code, deploying it there, and maintaining it afterwards. So I would say that the people in the team would be people that are well, diverse in their skills. Some of them have more infrastructure skills, but all of them know how to code, do the infrastructure as code in that way. But they also know how to do monitoring and all the other things. The cloud adoption model, well, it depends on where you're starting, and if it's like from scratch, I would say that one of the ways to adopt to the cloud is to automate everything. No, don't do anything by hand, and it takes a bit of an effort. Like Serhii said, the CI/CD of automatically deploying, that's one thing, but you can use the same tactics for the infrastructure provisioning. And so that's one way to do it. And I would say moving to the cloud, I like to stay away from the infrastructure as a service as much as possible, because maintaining your own machines, it kind of puts you in a difficult place for the automation, because you have to be inside of machines taking care of the operating systems, where you just want to be taken care of by the cloud resources. And creating elements in your solutions that are maintainable, are standalone and autonomous, allows you to be flexible in deploying various parts of your entire solution. So you don't have this monolith that you now put into the cloud, but just small individual pieces that can have their own life cycle. And that puts you in a good space for growing your team, because it starts with 3, but if you're successful, you will usually grow. And then you can have feature teams or multiple teams working together on the entire solution and utilizing more and more of the cloud.
Yeah, awesome. I think this is a very, very practical recommendation, and I fully second that skilling and skills and diversity are really important. And of course, jumping straight to at least platform as a service instead of infrastructure as a service will speed up your cloud adoption. Let's continue on the topic around cloud native and around microservices. So if we architect .NET Core application and we know that we want to run it in Docker and in Kubernetes later, any specifics you could highlight here during the architecture, during early stages of the development, just to make sure that we adopt all the best practices?
Oh yeah. Okay, that if you start using container technology and Docker being the current predominant one, take into account that whatever you're creating, your container images that are the deployable manifest through your application lifecycle management, is that they are immutable. And if you keep that in mind, you know that everything that will change across your stages from building to running in production can't be inside the image as a hard-coded thing. So the various environments and their specific configurations need to be externalized from your container image. And that is the connection strings, for example, web API endpoints, but also secret management needs to be taken care of in a different way. That all needs to be externalized. You need to read that from your environment. And luckily, the .NET Core and .NET 5 have excellent ways of reading environment variables and putting that as part of your configuration system inside of the .NET libraries. So that's one thing that you need to do. You need to take care of the networking, because networking inside of a container composition is different from reaching outside of your container. Not that difficult, but keep in mind that the URL endpoints and database connection strings or whatsoever might just behave a little bit differently inside of a container orchestrator. And I think that one of the other things that's also in regards to instrumentation and in that area is the health monitoring. And health monitoring is a good thing, because if you build in health monitoring into your solutions, you can actually cooperate with the container orchestrator, so it knows how your application is doing. And where Rosemary already highlighted Prometheus and types of metric that you can extract, being able to provide that information to a dashboarding for instrumentation, but also to your, let's say, your Kubernetes orchestrator, you can tell it how you are doing, if you're struggling or not. And giving the health information will allow your application to tell, I'm not ready yet to receive traffic because I'm still starting up, or I'm struggling, I'm performing less than I should be performing. So the orchestrator can decide to recycle your application, or it can do zero downtime upgrades, where it will fire up new instances of the new container image, where once they're ready, they will the orchestrator can shut down the old container images, and in that way just spin up new ones and do this recycling of the pods inside of your Kubernetes cluster from old to new, without any downtime at all. And that's all part of you being able to tell the orchestrator how you're doing. Mm-hmm. And finally, I think that if you start creating your application in small autonomous parts, we can call them microservices or anything else, do know that the container orchestrator takes care of your lifetime, and that you're reaching out into this diverse distributed environment, and you need to take care of things not being available at a certain point in time. So the resiliency patterns and cloud patterns, put those in your applications as well. So that would be the retry and timeout, but also bulkhead and other things like a circuit breaker, just to make your application behave well when it's under stress or when things are disappearing and recycled. So you should be a good team player inside of a environment that's very dynamic. And I think that taking that into account puts you in a good spot for a container-aware architecture of your solution.
Yeah. It's really amazing with current such a high requirements to the modern applications in terms of reliability and scalability. How important is to have not only the perfect code itself, but all the infrastructure, all the instruments, and all orchestration in place. So yes, of course, these are very crucial points when you start architecture. The next question, I think that in this event, we didn't give proper kudos to .NET 5, which was relatively recently introduced to the dev community, right? What's on top of mind? Any helpers came in this version which will help developers to build better, faster applications, maybe in the cloud context?
Okay, yes. Taking a look at how .NET 5 came to be, it's the successor to .NET Core 3, and they skipped to 5 to avoid any confusion with the .NET Full Framework version 4.8. But you can think of it as sort of as a unification of all the .NET platforms that were before the time of .NET 5. So that's a couple of things in the .NET platform. That's all the compilers and tooling. That's the base class libraries that are out there, and that's all the various platforms that you can target. And that's the cloud-based workloads. It's IoT, it's machine learning, and it's a whole variety of things. Even the Mono runtime allows you to run Xamarin-based solutions for mobile. So the broadness there is huge. So how can you become successful as a .NET developer for cloud? I think it's familiarity with everything inside of the .NET framework. There's been a huge investment in the base class libraries and everything supporting, for example, special memory management, fast network stack, to allow you to code really efficient, high performance pieces of code. And the platform itself takes care of doing everything to allow you to build highly optimized, compiled, small memory footprint, runtime versions of what you've built, so it can scale well in these cloud scenarios. So essentially, you can program the way you used to program. The platform takes care of doing most of the heavy lifting of getting high performance and a scalable model. And all you have to do is think about architecture and the patterns that you want to use inside of your code. So you can focus more and more on implementing the business logic, the things that really matter, versus having to take care of all the other things. Mm-hmm. And I think the ecosystem that we're in, it's open source, it's broad reach, not only giving you the cross-platform part where you can go across Linux, Windows, and Mac OS, but also I would call this cross-cloud because of all the library support that is there. You can just as easily run in Amazon Web Services or Google Cloud, because all the libraries, NuGet packages are everywhere. And so you can easily switch from one cloud provider to the other and integrate deeply into their cloud resources. If it's the AWS bucket or the blob storage in Azure, well, you can just switch around whichever one you prefer, using the same familiar languages like C# or Visual Basic, F#, and then still reaching these modern solutions.
Mm-hmm, mm-hmm. Yeah, super practical set of the features which will help to build applications faster and applications themselves better. And I believe developer experience we have with .NET 5 is close to being perfect. This is my very personal opinion. And talking about the modern applications, let's dive even deeper. So in my picture of the world, like in old times, we had the monolithic applications, then cloud native concept came, and we re-architectured everything to run as small services, microservices. And for me, the next step is to build and run fully distributed applications. This is like if you look at, for example, Kubernetes, this is sort of commodity now, right? So it's not it's something that you have almost by default in more or less every like medium to large project. So for me, distributed applications driven by Dapper or Service Mesh is sort of next step in this movement. So what are your thoughts on that? Did you try Dapper, and how is that related to a bit older concept, which is Service Mesh?
Yeah. Well, I did look into Dapper quite a bit to get familiar with the idea. Rosemary already mentioned the sidecar architecture and using sidecars to do certain cross-cutting concerns from your application. Dapper is exactly that. It's a distributed application runtime that allows you to code in a variety of languages. That's first. It offers an abstraction over patterns and resources that you want to use, like a publish-subscribe pattern, if you want to have that, or the actor programming model that's provided by the Dapper runtime, and it attaches a sidecar to you. The main difference between a Dapper and a service mesh is that a service mesh is largely focused on infrastructural concerns, such as proxying, doing A/B testing, for example, shifting network traffic from one version of a service to the other. It's largely for the operators to tweak and tune the mesh around your service in terms of network addressability and things on that level. It's not programmable, and the main difference with Dapper is that you can write code to interact with the distributed application runtime. So it's also like an application mesh. It does have an overlap with the service mesh. It gives some of the things like tracing and network discovery and reachability, and you can combine it with the service mesh, but it allows you to build your applications, not having to worry about what type of service bus am I using for my publish subscribe. It allows you to get tracing for free and just focus on the essential part of your code instead of all the plumbing that you would need to take care of otherwise. So it's a much faster programming model, much faster to do things because of the lower learning curve, lots of abstractions. And well, I think that given that you can just switch between cloud resources, you have a highly movable solution that you build on Dapper. And I think it's the next generation of building things that it borders closely to a serverless architecture. Because the thing underneath, it's your container orchestrator, can take care of all the instancing, the scaling, and other things. And if you take a look into the future, where it might just be very easy to to host a container image as a running instance and do scaling, then and you don't have to worry about clusters anymore. It's just there. You can just say, okay, I've got this container and just run it for me in this composition. Then attach the sidecars from whatever thing you have, such as Dapper. All of a sudden, you can just write these small pieces of code and get very rich functionality.
Yeah, exactly. So for me, this is looking very close to sort of operating system for some subset of programs. So I look closely at Dapper direction, and I really love this concept of sidecar in general. Okay, Alex, thank you very much for your answers. I see that we have discussion on YouTube live comments. So please, if you have some extra minutes, please join this. And there are some questions. To wrap up the event, what could be your advice, your recommendation to .NET developers, like something future looking, what to look at in some upcoming time?
Oh, wow. I would say take the bold step and start migrating your applications from .NET Full Framework to .NET 5 or from .NET Core to .NET 5. It's an effort, but I think that if you take that step, you have like a really smooth, clean ride to all the new versions that will be coming out, because they will be there quickly. Every year, a new major version of .NET 6, next year, 7 the year after, and so on. So get on the bandwagon, join the early adopters, so to speak. I think you'll love the experience, even though it might hurt a little bit, and you need to invest time and effort. But after that, it's plain sailing. So don't hesitate, don't wait, start doing.
Yeah, I second that. Thank you very much, Alex, and have a great evening.
Thanks, Maxim. Thanks, everyone. Bye-bye.
So, folks, it's time to wrap up the event. Thank you very much for being with us. Thanks for being active on YouTube Live with your comments, with your questions. I hope that you enjoyed the content we presented today. And I only have a closing word about our dear sponsor, a company called Intellias. And Intellias is a provider of full cycle software development services, operating since 2002. Intellias has 18 years of experience in helping leading European and North American technology companies in creating their products. And they are hiring. If you remember CI/CD session from Serhii from just a few minutes ago, you know what kind of company Intellias is. So they are cloud experts. They adopt all the best practices, and they invest in skilling of their employees. So just have a look at the open positions they have. On that, thank you very much. I'm Maxim Salnikov. I was with you on during this 2 hours, and stay tuned. We'll come up with more build apps soon. Bye-bye.